Have you ever thought about the origins of music and its enduring presence throughout human history, or how the vibrations of a guitar string or beat of a drum translate into the melodies that stir our souls? What about the profound effects of music on our brains, emotions, and well-being? Well, today we're diving deep into the science of music and its impact on the brain. Music has been an integral part of human culture for millennia, with its origin tracing back to prehistoric times. Early humans likely created rhythmic sounds using primitive instruments such as drums, flutes, and stringed instruments made from natural materials. The emergence of popular music in the 20th century further expanded the musical landscape, with genres such as jazz, blues, rock, hip-hop, and electronic music shaping modern musical trends and identities. Now let us move into the physics of sound in music, starting with sound waves. Imagine you're standing by a pond and you toss a paddle into the water. Ripples form and spread out from where the paddle hit the surface. These ripples are a bit like sound waves traveling through the air. When something makes noise, like a guitar string vibrating or someone speaking, it creates vibrations in the air molecules around it. These vibrations move outward in all directions, forming waves that our ears can detect. Secondly, we have frequency. Frequency is how often something happens over a certain period. In the case of sound waves, it's how many vibrations occur in 1 second. Think of plucking a guitar string gently versus plucking it harder. When you pluck it gently, it vibrates fewer times per second, creating a lower pitched sound. The lower number of vibrations corresponds to a lower frequency. But when you pluck it harder, it vibrates more times per second, producing a higher pitched sound with a higher frequency. Then we have pitch. Pitch is how high or low sound is perceived to be. It's closely related to frequency. Higher frequencies create higher pitches, like the sound of a bird chirping, while lower frequencies produce lower pitches, like the rumble of thunder. You can think of pitch as the highness or lowness of sound. Then we have wavelength. Wavelength is the distance between two consecutive peaks or troughs of a wave. You can imagine it as the length of one full wave cycle. In sound waves, shorter wavelengths correspond to higher frequencies and higher pitches, while longer wavelengths correspond to lower frequencies and low pitches. For instance, the sound of a high-pitched whistle has shorter wavelengths because the vibrations happen more frequently, while the sound of a low-pitched drum has longer wavelengths because the vibration occurs less frequently. Now let us explore how the physics applies to music, starting with sound waves in music. In music, sound waves are the building blocks of all the sound we hear. When a musician plays an instrument or sings, they create vibrations in the air, which travel as sound waves to our ears. Each musical instrument produces its own unique set of vibrations, resulting in different sounds. For example, a guitar produces sound waves when its strings vibrate, while a drum creates sound waves when its membrane is struck. Secondly, frequency and pitch in music. Frequency and pitch are crucial elements of music, determining the perceived highness or lowness of musical notes. Now let us break down the neuroscience in music. Music has a profound impact on human cognition and emotions. When we listen to music, various areas of the brain become activated, including regions responsible for auditory processing, emotion, memory, and motor control. For example, studies have shown that the auditory cortex processes the basic elements of music, such as pitch and rhythm, while the limbic system, which is associated with emotions, responds to the emotional qualities of music. Additionally, music engages the prefrontal cortex, which plays a role in decision-making and executive function, suggesting that music can influence our thoughts and behaviors. Moreover, research has demonstrated the powerful effects of music on mood, memory, and cognition. Music has the ability to evoke strong emotions, such as happiness, sadness, or nostalgia, by activating the brain's reward pathways and releasing neurotransmitters like dopamine. Furthermore, music has been shown to enhance memory and cognitive function, with studies indicating that listening to music can improve learning, attention, and problem-solving skills. Recent scientific research continues to uncover the therapeutic potential of music, including its use in treating neurological disorders such as Alzheimer's disease and Parkinson's disease. By shedding light on how music affects the brain, scientists are uncovering new ways to harness the power of music for cognitive enhancement, emotional well-being, and therapeutic intervention. In conclusion, we've seen how music has been with humans for ages, bringing joy and inspiration. From its beginnings in ancient times to today's research, music affects our brains, emotions, and society in powerful ways, whether it's understanding how sound works, how our brains react to music, or how music helps us heal. Now, if you found this video informative, hit the like button and let me know in the comment section in what profound way has music impacted your real life. Subscribe to the channel, and until next time, stay enthusiastic.